This is Mr. Antrim, another Chemcast. This one is on chemical nomenclature practice. You should attempt this practice Chemcast after you have completed most of your study guide and have at least gone through the rules for naming ionic compounds and also the molecular compounds. So here we go. Here are 10 compounds, and you are to write the names for these. The answers will be given at the end. So my suggestion would be to pause this and on a sheet of paper write out all the names using the rules and nomenclature that we have learned. Once you've done that, we will go on now to the second set of questions. In this case, you're given 10 names and you're being asked to write the correct chemical formulas for these. Once again, the answers will be given at the end, so at this point you should pause and write the correct formulas for these 10 compounds. We'll now go through the answers, but again, make sure to make this a valuable experience that you have tried them yourself. So here we go. Here are the 10 compounds whose formulas are given. You are to write the names. First one, K2O. Answer, potassium oxide. Remember, this is an ionic compound. The first thing you see is a metal, so we know it's ionic. It's a group 1 metal, potassium, so I know it does not need a Roman numeral. We're just going to call it potassium oxide. Second one, it's ionic. We see the first element is a metal. And here we have a polyatomic ion. You can look that up. Eventually we'd probably ask you to memorize those. But this is simply going to be called calcium nitrate. NO3 is nitrate. It has a -1 charge. Calcium is in group 2. Group 2 elements always form +2 ions, so there's no need for a Roman numeral. Next one, we have iron, and we have a polyatomic ion. You look this up, it's carbonate. So you know it's ionic because the first element is a metal, but you also notice that this is a metal that's in the transition area, so it needs a Roman numeral. The correct name for this compound is iron 3 carbonate. Remember, carbonate, you would look up, it's -2. We see it took 3 of them, so we know there's a total of -6 charge. We need to have a +6 charge. If there are 2 iron ions, each one therefore must be +3. So we need a Roman numeral with parentheses 3 to correctly identify this compound, correctly name it. There's also a compound called iron 2 carbonate, and it would be a compound that has different properties than iron 3 carbonate. Here is, once again, an ionic compound. First element is calcium. That's why I know it's ionic. First element is a metal. And it's also a group 2 metal, which means it does not need a Roman numeral. We simply call it calcium iodide. Next compound, SO2. First question we ask ourselves, is the first element a metal? And in this case we see, no, it is not a metal. We know it's not an ionic compound, it is a molecular compound. We're going to use the prefix system. This compound is called sulfur dioxide. Number 6, silver, and then we have a complex or a polyatomic ion. If you look this up, this one is known as chromate. Silver is a metal, so we know it's an ionic compound, but silver, although its transition was one of the exceptions, does not require a Roman numeral. Silver is always +1, so we just simply say silver chromate. It's one of the exceptions of the transition element that does not need Roman numerals. Copper, transition metal, we know it does need a Roman numeral. ClO3 is chlorate. Chlorate is a polyatomic ion. Look it up, it's a -1 charge. We notice it only took 1 copper to go with 1 chlorate. Chlorate is a polyatomic ion, a group of atoms that has a charge. So this would be called copper 1 chlorate. And once again, I know it's copper 1 because it only took 1 copper to go with 1 chlorate. And chlorate we know is -1. Again, an ionic compound for number 8 because I see a metal. SN is a metal. Tin is a transition metal, therefore, and it's not one of our exceptions, therefore it needs a Roman numeral. What Roman numeral? Well, SO4 we know is sulfate, or you look that up, and it has a -2 charge. Notice it took 2 sulfates. So 2 times -2, we have a total of a -4 particle here. A total of -4 on the negative anion. So therefore we know we must have a +4. There's only one tin to equalize or neutralize this -4, so it must be the tin 4 sulfate. Once again, it has to be Roman numeral, and it has to be in parentheses, tin 4 sulfate. Next one, zinc, and then this pretty complex looking polyatomic ion you'll start to recognize, or you can look it up, is the acetate ion. It's -1. Well, zinc is a transition metal, but it is like silver, one of those exceptions. It does not need a Roman numeral. Zinc is always +2. And the last one, first element, is not a metal, so we know it's not ionic. It's a molecular compound, and we simply use the prefixes, in this case, diphosphorus pentoxide. So this is a good set of 10 compounds that cover almost all the rules that we have learned for naming compounds at this point. Next, we were given names, and we were to write formulas. First one, aluminum nitrite, would be simply AlNO2. NO2 is the formula for the polyatomic ion nitrite. It is a -1 charge. Aluminum, we have learned, is +3. We learned that aluminum wants to or needs to lose 3 electrons to become stable, get that S2P6 arrangement, that octet. So aluminum is +3, nitrite is -1. It's going to take 3 nitrites to go with 1 aluminum. So in the compound, the ionic compound aluminum nitrite, in that crystal, there would be 3 nitrites for every 1 aluminum. This is the 1:3 smallest whole number ratio of ions in the compound aluminum nitrite. Copper 1 sulfate would have this formula. Copper 1, that Roman numeral 1, if you recall, means it has a +1 charge. So if copper has a +1 charge, sulfate, you can look up, is a -2. Well, it took two coppers, so each copper must be a +1. So the name copper 1 sulfate would have this formula. Remember, the Roman numeral does not stand for the subscript, it represents the charge. Barium hydroxide has this formula. Barium is Ba, hydroxide is OH, and it has a -1 charge. It's very easy for people to forget to put parentheses around this one. You need parentheses, otherwise it would look like you meant OH2, which would mean 1 oxygen and 2 hydrogens, when we actually mean there are 2 hydroxide ions. So I have to put parentheses here. Ammonium dichromate, pretty complex looking formula here. Ammonium, well, that's not an element, that's a polyatomic ion. You can look that up. It's one of the few polyatomic cations. Dichromate is a polyatomic anion. Ammonium is NH4, it has a +1 charge. Dichromate, Cr2O7, has a -2 charge. Therefore, it takes 2 ammoniums to go with 1 dichromate. Nickel 2-phosphate would have this formula. Remember, the 2 means the charge on the nickel would be 2+. Nickel is a transition metal. It can form different compounds, different ions. In this case, it forms the ion as a 2+. So phosphate, we look up, is -3. Compounds are neutral. It's going to take 3 nickels to go with 2 phosphates in the crystal compound nickel 2-phosphate. Disulfur pentachloride. Well, this looks different from the others. All of a sudden, we see these prefixes. we know it's two nonmetals, a sulfur and chlorine. So these are actually pretty easy to write formulas for if you just know your prefixes. Sodium hypochlorite has this formula, sodium ion plus 1. This ion is known as hypochlorite. It's ClO. If you look on a bottle of bleach, it will say active ingredient, sodium hypochlorite. Potassium phosphate would have this formula, mercury 2 acetate. There's that acetate ion, pretty complex polyatomic ion, C2H3O2, has a -1 charge. It's going to take 2 acetate to go with 1 mercury. And this is a pretty tricky one, dihydrogen monoxide. There you go. Of course, chemists would simply call that water. So, hopefully you did all right on these, and this is an excellent review, these 20 problems. Your quiz and tests over chemical nomenclature will look just like this.